Hi, so I'll be explaining the video that was attached for the Interactive Advanced Concept Presentation 6 on nuclear bombs and reactions. Okay, so as this reaction was probably most likely too dangerous and complicated to set up at home, we were able to watch a guided lab video on how those reactions work instead. So this experiment specifically was on the nuclear chemistry that was necessary in order to produce a nuclear bomb and or reactions. So feel free to follow along as well on the slides, but I have a couple of notes and I'll just be reading off of them and adding more critical information. So nuclear bombs, this slide will be on how nuclear bombs are made and how they work. So to start off, there has to be a chain reaction of the fission of heavy nuclei. So there are a couple of elements that are capable of producing this type of reaction. So the first one is uranium-235, which is radioactive. And it does exist in other isotopes, which is why uranium, the element, has a few other numbers by it. So it also exists as uranium-234 and 238. However, specifically just to uranium-235 isotope, only 235 can produce that type of explosion in nuclear reaction. However, in order to produce it still, there are caveats where there must be at least greater than 80% of it in order to produce that type of reaction. So in the chances that uranium-235 is unavailable, plutonium-239 can be used. However, to note, plutonium-239 tends to be rare in nature, and since it is rare in nature, it is more typically found man-made. It launches due to the mass of fissile material, which is called critical mass actually. And when this mass reaches a nuclear decay reaction, it is then formed with release of energy. But only one critical mass is not enough to produce such a wide-scale reaction. Around 4 to 5 critical masses is what it takes to set off a large explosion. To put it into perspective, like a ball that explodes, the middle of the ball shrinks towards the center of the shockwave to then allow the density of the uranium or plutonium inside to increase, which is then what kind of causes that nuclear explosion. Going on to the last slide is the hydrogen bomb. So this is one that I was really interested to learn about just because this is a bomb, I guess, that is more discussed just because it is a little bit more dangerous, as I've heard and learned. And so to get into it a little bit, the other bomb that we're going to be explaining, the hydrogen bomb, is caused by thermonuclear fusion instead of the other types of reactions that we had earlier. So this reaction takes place inside of the charge with the assistance of elements such as tritium and deuterium. Sorry if I didn't pronounce those really well. And the main effective substance in it is lithium hydride. So the detonation of lithium hydride is carried out by an integrated nuclear device, which also in layman's terms known as a detonator. And essentially, it detonates when active energy is released. It then triggers the explosive thermonuclear reaction inside of the bomb. The unique capability of this bomb, however, specifically comparatively to the other bombs we brought up, whether it was the uranium-235 that was contributing to the nuclear reaction or plutonium bomb, this bomb is different, and that is specifically unique as well for the destructive capabilities that it has, which do tend to be more plentiful comparatively to the other bombs that I named. And so, I mean, the capabilities are kind of endless, depending on the way that you construct it. And obviously scientists don't know all of the entirety of capabilities just because they still have not potentially constructed something that is that destructive, but depending on the way that it's constructed with potential, it could bomb or destroy all of Earth. So it could wipe out most of humanity or life on this planet. And so that is the reason why obviously hydrogen bombs are taken into consideration a little bit more differently than other bombs are, with their unique capabilities of destruction. So hopefully we learned something from this. I know I definitely have. I didn't know a ton about bombs, so it was really interesting looking into it a little bit more and getting to kind of do this activity and presentation on it. So I appreciate the opportunity to do that, and I thought this was a pretty cool experiment to just kind of look into the reactions a little bit more. So thank you.